I have an experimental setup here. Very simple one, very jugado one. I'll just tell you what and all I've used here. So I need a voltage source. Okay. For that I have this, I don't know whether everyone can see. I'll show it later. I have one black box. Okay. It's not a laptop charger. I have one black box. That is nothing but one of our boards. Like my company works on such boards. In that, what will happen is AC to DC conversion will happen. About this we'll talk sometime later. Just remember, it's a voltage source. I need a battery, right? With a simple small battery, I cannot do this. So I have taken a big battery. Let's assume it that way. That black thing is a battery. Next, wait, I'll just draw my experiment setup. So I have taken one battery. Okay. Then I have this circuit right here. Okay, I have this circuit right here, which is nothing but my conductor. Okay, nothing but my conductor. Okay. Now, if I want to know whether when I change the voltage, current also changes, I have to measure it, correct, right? Without measuring, how will I know? So what device is used to measure current? What device is used? We use ammeter, correct, right? What device is used to measure voltage? Voltmeter, correct. So I have to connect ammeter and voltmeter. Okay. Now how do I measure current? Like ammeter, how is it connected? There is a specific way for you to connect ammeter. Only then, yeah, very good. Only then it can measure. Ammeter has to be connected in series with the circuit. Series means I have to break this circuit open and then connect an ammeter, correct, right? Yes. Okay. How do I measure voltage? I have to connect voltmeter in parallel with the circuit. Am I right? I have done the same thing, but instead of using ammeter and voltmeter, I have used something called as a multimeter. Now, what is this multimeter? See, ammeter and voltmeter, right? They have specific functions. Okay, ammeter simply measures current, voltmeter simply measures voltage. And if you see in videos on YouTube and any laboratories and all, you'll be having something like this. Okay, you'll be having, and here there'll be numbers, and you'll be having a needle that will show what is the current, what is the voltage, will show. But we don't have that facility. Instead, I've got a multimeter. So multimeter is like a very handy device for anyone who works on electronics. Okay, so multimeter, right? It has everything. You can use it as a voltmeter, you can use it as an ammeter, you can use it as an ohm meter, maybe to measure resistance. Okay, you can do lot of things with a multimeter. So I have got a multimeter. Okay, so one of the multimeter will be acting as an ammeter, one of the multimeter will be acting as an ammeter, other one will be acting as a voltmeter. So the big one here, okay, the big one that will be acting as a ammeter. Okay, the big one right here will be acting as an ammeter. The small one will be acting as a voltmeter. So this, okay, did you understand the setup now? So what we are trying to do? We are trying to see what happens when I change the voltage. When I change the voltage, what happens to current? Okay. So I'll actually set different voltages. I have a setup for that to set different voltages. You guys, what you have to do is, you guys have to see this meter, write down what is the voltage. See this meter, write down what is the current. Then we'll do some calculation based on that, and we will verify whether Ohm's law is correct or not. Is that clear? Is the setup clear what I'm trying to do? Don't worry about the electronics involved. That is not something to worry about. But the main funda is simple. I have a battery where I can change voltage. Okay. I have a conductor so that the current passes through that. I have an ammeter, that is the big one, that is an ammeter. Okay. I have a voltmeter to measure voltage. Is that clear? Everything clear? Okay. So we'll start our experiment. Fine. Okay. So let's try to change the voltage now. This is 3.6, right? So let me try to make it 4. Is it changing? 3.7, 3.8, 3.9. Is it 4 now? 4.032. Okay, now you just make two columns, one for voltage, one for current, and write down the readings. One for voltage, one for current. So write down the readings. Voltage it is 4 volt. Okay, 4 volt. Current it is 3.7 milliamps. Voltage is 4 volt. Current is 3.7 milliamps. milliamps. Next, let us change it. Let us increase it. Okay, we'll see. What is expected when you increase it? When you increase the voltage, what should happen to current? Should increase, right? So let us increase it. Let us increase it to 45. 6 volt. I mean, everyone is able to, understand it, what's going on. Nobody is blank, right? Okay. So what is this? What is the voltage now? 6 volt. Here it is 5.5 milliamps. Okay, just write down 6 volt and 5.5 milliamps. Okay. Okay. So now let us change it. Let us do 8 volt. Okay, this is almost 8, 7.99. We can write 8. Okay, so 7. It's reading 7.99 volt. We can take it as 8 volt. And here, what is the current? 7.3 milliamps. Okay, let's take one digit. It's okay. So 8 volt is 7.3 milliamps. Okay. So because we are getting more points, because we have to draw the graph also later. Okay, graph for Ohm's law is also important. I'll take the experimental values and only I'll draw. Okay. So now 8 volt is the next is 10. We'll go for 10. We'll increase in 2 digits. Okay. So you have 10 volts. So 10 volts, what is the current? 10 volt, what is the current? 9.24 milliamps. Okay. So, we can continue going in terms of 2. Okay, we'll quickly do it. Okay, we'll quickly do it. You guys tell me, I won't write it over this. You guys go on writing. I'll quickly change the current. 12, 14, 16 till I can go up to 22. Okay, my setup allows me to go up to 22, so we'll do that. Okay. So, okay, now write down. For 12, what is it? 11.17, or you can write 11.2 or 11.1. Anything is fine. 11.2, right? 11.2. Okay. Now we'll increase to 14. Okay, now 14.1. I'll try to decrease it a little. A fine adjustment is a little difficult here. And my hands are shivering as always. Perfect. For 14, what is it? 12.9. I can write 13. It's almost close to 13, right? Write 13. Okay. See, perfect. Then we'll go for 16. Okay. So 16 it is 14.8. You can write 14.8. So we'll go up to 20. 28 is enough. It will not go too much. Then 18. This is enough. Right, 18. Yes, it will come to 18. Oh, yes. For 18 volt, it is 16.6. Okay, one more reading and we'll stop and we'll try to analyze the readings. Okay. So one more reading, that is 20 volt. We'll stop that. I will try to analyze the reading. Okay. Okay, we can write 20. Just write 20 volts. Just write 20 volts. And you write the current 18.8 milliamps. Okay. What does Ohm's law say? Tell me Ohm's law again. Define Ohm's law for me. The current flowing through the conductor is directly proportional to the potential difference across the end. What do you mean by directly proportional? When one quantity increases, the other quantity also increases along with it. As I increase the voltage, did the current also increase along with it? Correct. No, it was 4, 3.7. When I made it 6, it became 5.5. When I made it 8, it became 7.3. It increased, correct, right? So that is what directly proportional means. When you increase the voltage, the current also increases. Okay. So Ohm's law is actually verified here. Okay, when one quantity increases, other quantity also increases. But what we'll do is, we'll take the ratio of this. What I want you to do is, I want you to quickly calculate. You guys are good in math, right? So quickly calculate what is V by I for all the readings. Make one more column. Make one more column. V by I. I want you to quickly calculate what is V by I for all the readings now. So while calculating, you can simply do this. See, easiest way of calculating. One calculation I'll do. So first calculation, it is 4 volt divided by 3.7 milliamps. Correct, right? Milli means it is 10 to the power of minus 3. Do you agree? Take the 10 to the power minus 3 to the numerator. Okay, so it becomes 4 into 10 to the power of 3 divided by 3.7. Now divide this and write. No matter what voltage I give and what current I get, when I divide those two values, am I getting the same answer? Almost the same answer. Correct, right? This is actually what shows that voltage and current are directly proportional. See, directly proportional, what I told is not 100% right initially. What did I tell? I told that when one quantity increases, other quantity also increases. This is directly proportional. This is not 100% true. Actually, what is directly proportional? If I have 1 volt, I get 2 amps. If I have 2 volts, I get 4 amps. If I have 3 volts, I get 6 amps. Okay. Now, when I double the voltage, the current doubling. When I triple the voltage, the current tripling. Okay. If I take the ratio, am I getting 2 everywhere? Scaling factor. Correct, no? 6 by 3, 4 by 2. This is directly proportional. When I take the ratio, I should be getting the same value. So in this case, am I getting the same value? Correct, no? So, what is that value actually? Voltage is directly proportional to current. If you want to remove this proportionality constant, if you want to remove this proportionality symbol, you have to introduce a constant. That constant is nothing but R. And this is that R. When you divide V and I, whatever value you get, that is that constant, that is R. That is nothing but the resistance of the material. When you divide voltage and current, the value what you get is the constant. That constant is nothing but the resistance of the material. Every material will have some resistance. Okay. Now what is resistance? Resistance is something that will oppose the flow of current. Okay. It will actually not allow the current to flow. It will stop or reduce the flow of current. That is resistance. I'll give you a simple example. If you consider current, or if you consider vehicles moving on the road to be current, okay, faster they move, more current, slower they move, less current. Okay. Your accelerator pedal to be voltage. Okay. Now if you increase the pressure on the accelerator pedal, will the vehicle move faster? Correct. But can it move to infinite speed? It depends on how good the road is. Correct. Now if the road has many potholes, can it move faster? Even if you increase the accelerator, can it move faster? It cannot, right? That potholes is what reduces the speed of the vehicle. Do you agree? This is that pothole. This is the resistance. Resistance is something that opposes the flow of current. It will actually reduce or stop the flow of current. Is that clear? So this is Ohm's law. So what did we learn from this? When you increase the voltage, current also increases. When you decrease the voltage, current also decreases. That is, current through the conductor is directly proportional to the potential difference if temperature and other physical conditions are kept constant. I cannot do that experiment here. I cannot increase the temperature or decrease the temperature and do, but if you change the temperature, actually this reading will change. Okay, if you do this experiment at 25 degree and if you do this experiment at 45 degree or 55 degree, this won't give you the same answer. Okay, it will give you a different answer. So that means it is not proportional. Are you getting my point? Even if you change the length of the conductor and all, it is changing. Okay. Now how do I confirm that whatever value that I got from Ohm's law is correct or not? If I am able to measure the resistance of this, then can I confirm? Now whatever I got is through calculation, correct? Now if I divide V and I get some value. Okay, but what if I have some meter that can directly measure the resistance of this? That time I can confirm, right? Actually, your multimeter gives you that option. From your multimeter, actually you can convert that into an ohm meter also. You can actually check the resistance of it. Okay, so I'll tell you about resistance and all. Don't worry, I'm actually might be going a little bit faster. But to confirm that our experiment is correct, we'll do one thing. I'll just take this. Put it here and I'll change this to this symbol right here and I'll just remove this one or this one, and I'll keep it across my conductor. I'll try to measure the resistance of my conductor. Tell me what value it is showing there. 1.08. Correct, no? Is that the same value that we got through our calculation? That is the resistance of this material.